Hello, this is Greg Crinklaw, and this is the introduction to the nightly planner of SkyTools for Visual for the beta testers. And there's a lot to go over here. Some of it is old, some of it is new, most of it is someplace else from where you expected it to be. There are a couple key concepts that are introduced here. So what I'm going to do is I'm also going to create a PDF file to sort of explain some of these features, and that will go out with the beta test. But for now, we'll just do an introduction, and I'll show you how it works. Across the top are the standard settings. You notice that if you click, you can choose a location, but if you click on the gear, it brings up the settings dialog for that thing. So here are your locations. Here's the settings dialog for telescopes, or we can just select a telescope. And that's something used throughout the software. So look for that little gear icon, because that means you don't have to go looking for the setup here. It'll always be there wherever you're selecting a telescope. So here's the night bar. Same old night bar, but it's got a new addition. And that is this blue line here. Okay, so reminder, the red dashed line is the altitude of the object. In this case, it's the selected object, which is the dumbbell. And of course, the shading is the background sky brightness. This blue line here is the relative quality of observation for the dumbbell throughout the night. And that is a really key concept because it's built into just about every calculation that SkyTools 4 does for you. So let's talk about what it can model, what it can calculate. And there's basically three things that it can calculate. The first is, what's the faintest star that I can see? So the faintest star you can see in your telescope from your location with your light pollution or whatever, let's say it's a 15th magnitude star. So if you're looking for a faint quasar and it's 15th magnitude, that's going to show up as very challenging, right? And if it's brighter than that, maybe it'll be difficult, and if it's even brighter still, it'll probably be obvious. So that's how the calculations are done for stellar objects. The second thing it can do is it can calculate what the resolution is, what level of detail you can see. And that's going to depend on the seeing, right? And it's going to depend on your telescope, and it's going to depend on the altitude of the object in the sky. That's most important for things like planets, or the sun, or the moon, right? So that's the second thing it can do. It can calculate what's the best level of detail that I can see from my location in my telescope. The third thing it can do is it can calculate the contrast for an extended object, say like the dumbbell nebula. How much contrast do we have between the nebula and the background sky? And again, we can calculate the best contrast that we can achieve for our telescope and our location with our background light pollution. Once we know these bests that we can do, then we can calculate it for any given time of the night. And depending on the type of the object, in this case it's the dumbbell, we can say, well, what matters most about the dumbbell is the contrast. So we're just going to use the contrast model. And at 5 p.m. tonight, we can't even see it. So this blue line is going to be all the way at the bottom. And as twilight continues, it's going to start to become visible, and it's going to become, the contrast is going to get higher and higher and higher and higher until we reach a maximum here. But you notice that the dumbbell is setting, right? So that contrast is going to start going down and down and down and down until we can't see it anymore. And this is how we define the quality of our view at any given time. And if you look below the night bar here, there's this new bar here that's colored. And it looks at this quality line and says between this time and that time is the highest quality or the best quality, and it colors that as green. Between this time and this time is at least fair quality, and it colors that as yellow, and then everything else is poor quality or it can't be seen at all. Now, that gives us the ability to say the best time of night to observe this thing on this night is between this time, and if we go down and we look at the begin, best, end columns, 6:10 to 9:10 is the period of time to best observe it, with the very best coming at 6:36. And I'll move this here. We can see that's colored green. And this is colored green because it achieves the best quality of green, and this is that time period. Down here, this one here only achieves a yellow quality. See? And this is that time period that's displayed here. All right? So what this will do is it means we're not going to have to use any other filters. All we have to do is say this is the best time of night to be observing this object, and it takes into account the aspects of that particular object. If it's a bright open cluster with the faintest star is 4th magnitude, that's a completely different thing than a big wide nebula, right? So it takes that all into account. So that's the first thing to understand, and that's this blue line here on the night bar, and then that's summarized below that into blocks of the night. Underneath that is our difficulty level, and you're familiar with that already. This is the obvious difficulty, and it's obvious for most of the night. As it's rising here, it goes through difficult and easy, and then it goes back down through the difficulties again. So this second bar here just tells us the difficulty where green is obvious. So on this bar, green is best. On this bar, green is obvious. And I'll show you how we're going to use that for planning in a minute here. The next thing to do is let's look at how we select a target list. There's a whole new way of doing it. Before we had groups and then lists, and now we have folders like current and lists within each folder. You can grab a list, drag it into another folder. This is a much easier way to deal with it. We can click View Edit to change the details. We can delete them. We can create a new list here. All right. Next is the weather. We talked about that a little bit in the introduction video for setting things up. If you're planning far in advance, you select Auto, and it'll use that typical monthly value throughout the year, or you can tell it exactly what you think it's going to be tonight. You can set the seeing. You can click to enter temperature. Let's say 12 degrees Fahrenheit. I'm just going to put an F on there, and that F then tells it to use Fahrenheit, and it had to go and recalculate everything. Same with the relative humidity. We're going to talk about this in a little bit, so I'm going to skip past it. Next is attachments, and I would really like to see more people use the attachments in SkyTools 4 than in SkyTools 3. I think one of the reasons people didn't use the attachments, and attachments are notes, links to websites, and images that you can attach to a particular object. I think they were too complicated, and it wasn't integrated into the observing list in a simple way. So I've simplified things, and I'm hoping that means people are going to use it. So there are attachment folders, right? And a lot of times each of these folders goes along with an observing list. So you could have a folder just for the Messier list, and any attachments you make will be attached to objects in the Messier list. And then if you select the Messier list as your attachment folder, they'll all be displayed here. And that's really the best way to do it, is to create an attachments folder for each of your lists. But you could also just have attachment folders that are broader than that, like say My Attachments. And one of the changes here is before you could have images, plottable images, web links, notes, and each of them had their own folder. Okay, so right now there's just one folder. So there's one folder. This My Attachments folder holds notes, images, web links for each of the objects. And if you look down here in the attachments column, there's an N and an I here. That means that this object has notes and images, okay, in this attachment folder. If I change the attachment folder to something else, and it shouldn't have to recalculate that. That's a bug. I'll work on that. Now it doesn't show that anymore because there's nothing attached to that object in that folder. And again, these are attachments that are designed for the Herschel 400, and that's not the list I have up. So I'm going to put back what I had before, which is just my general attachments folder, and that's the default that'll be there when everybody starts up the software. Okay, so now I'm going to skip over the filters for now. We're going to come down here. Here are list functions. These will look fairly familiar. By the way, the thumbnails are one of the things that's not turned on yet. I'm working on those right now. They're coming soon. Everything else is very similar to the way it used to be. This is how we control the column schemes now. There used to be a little button over here. Now we just display it up front, and again, you can select the column scheme that you want, or you can click on the need to fix that. Need to click on the gear icon. This is a perfect example, by the way, during beta testing. You open this up and you say, I didn't want to do that. I wanted to click on the gear. Well, that time it worked. Well, often when this is open, you can't click on the gear. See that? So that's the kind of thing I want to hear about, because maybe I got used to it, maybe I forgot about it. That's something we'd like to catch. So if we click on the gear, here are all the columns. And you can see there's a lot of columns. And the columns available aren't necessarily appropriate for each type of list, right? There's a bunch of double star columns, for instance. We don't have those turned on because these are Messier objects. So we're going to create a new column scheme for double stars, and we'll do that in a little bit. This is how we add objects. Bring up the designation search. There we go. It's all set to add to the list that we have up. We type in our objects. This is exactly the way it was before. We can browse objects. We can just type them in here. Or we can bring up the database power search. Again, not a whole lot has changed here. There's this whole minimum quality for a specific night down here. But other than that, it pretty much works the same way as it did before. So what does this do? Well, it adds objects to an observing list. So that's why it and the designation search are under add objects here. Next thing is getting observing lists. Well, here are all the tools for getting new observing lists. There's the nightly observing list generator. It hasn't really changed much, but there it is. There is, we can browse the website. So here are the lists that are available at the Skyhound website. We can read an STX file, or we can read a list of objects by designation from a text file. So all these things are right here, and I think you'll find that that's much more convenient. You don't have to go looking for them. If you look around, you're not going to find the data manager. It's gone. The data manager has been replaced. The idea behind the data manager was to have one place where you could manage everything, which I thought would be a really good way to do it, because then you'd always know where to go. The problem was a lot of people forgot the data manager existed, and it was just an icon at the top. You'll notice all the icons are gone. I kind of hated those anyhow. And if you didn't remember the data manager existed, then you were lost, right? It was all or nothing. So now we move the data either up here under the data tab. Here are a lot of the things that used to be on the data manager. Here are your comments, for instance. Or it's put right here where you're actually using it. Okay, so the next thing is sharing observing lists, and right now we just have one option, which is shared as an SCX file. There's going to be a second option here before too long where you can share your list and upload it directly to our website. And over here under Get Observing List, there'll be another option to go look through the user submitted observing lists. So I don't have to put them up anymore. You can build a list put it up on the website, other people will be able to immediately download it. So those are all the things related to observing lists across here. And of course, we talked about setting a column scheme. We can change the width of the columns just as before. They're remembered. We can drag a column anywhere we want to, just like before. So now let's look at filtering all this. The filters are across here. Okay, so we can filter by class just like before. So let's just show galaxies. There's just galaxies. We can filter by constellation, select multiple constellations if we want. That's an improvement. We can filter by whether they're logged or not. And now we get to the main filters: quality and difficulty. And so we talked about quality. These are objects that have a green quality during the night. This one's from 3:20 to 5:30 a.m., right? So that has a green quality. This one never even arises during the night, so it doesn't have a quality at all. This one's got poor quality. So what we can do is we can filter by quality. So I'm going to say fair or better. So now only the objects that reach yellow or green are shown. If I go for best quality, which is really the best thing to do, only objects that reach their best during the night are going to be listed. So you no longer have to worry about things like setting a specific altitude or a specific sky brightness, because if you think about it, that's a general kind of thing. And what SkyTools can do is you can do a calculation for each specific object. So really, we don't want to be just setting a general thing and say, well, I want it to be above 2 air mass, because some objects are well observed below 2 air mass. Other objects really need to be above 1.5 air mass. By using this quality, it's customized for each individual object. So now we really get to what we really want to be getting at directly. Okay. The other thing is the difficulty filter, and you see there's a difficulty column here. Obvious, easy. You're used to seeing all that, and just to note, just as before, anything that depends on the time of night, any of these columns that depend on the time of night, like the air mass here or the difficulty, is computed at the optimum time, or I've changed the name of that to the best time. So this is calculated for 8:24 p.m. And now we get to the ideal eyepiece, which is also calculated at that time. And this finally is a true ideal eyepiece. Before, it might have said optimum eyepiece, whatever it said before, but that was the optimum eyepiece for detection, right? So if you had an object that was almost too hard to see, it would tell you which eyepiece to use to give you the best chance to detect it. But for an obvious object, that didn't mean anything, right? So this eyepiece, ideal eyepiece here, will do what it did before, but if the object isn't difficult to detect, it's going to do something else. And that something else is generally to give you the best aesthetic view. And that's going to depend on the type of object and so forth. You notice that here it's suggesting a different eyepiece than here, and that's because one object is much bigger than the other, and this is a wider field eyepiece. Back to attachments a little bit here. So here are, this is an object with some things attached. I'm going to double click on the end.
Cigar Galaxy is a nearly edge on a regular
All right,
galaxy
you hear that?
in Ursa Major. It is magnitude 9.0.
It's
with
talking.
A parent size of 11
Okay.
by 5.1
Now,
arc
you might
minutes.
find that annoying.
Cigar Galaxy is currently located fairly high in the...
So I turned it off. Okay, so don't freak out the first time you hear that. The default is probably going to be on. Other than that, this is the same old object information dialog with a few additions. One of those is the ability to speak, and you'll see why that's going to be important when we get to the real-time tool because of a new feature. You can customize what it says. So you can have it give every bit of information that's on this dialog, including reading your notes down here. Or you can say, just give me the basic stuff. So here's the number of designations I don't even want another designation. I just want the primary designation. Read the brief only. That's just whatever's in here. Give me a list of nearby objects, or don't. You have complete control over that. So if you find it too annoying, you can have it just say a very brief part of what's here, or you can have it go into great detail. We're just going to leave it off for now. So here's the notes tab. I'm going to type in a brief, type stuff, and then there's more stuff down here. Okay, so when I close that, that brief text that I typed shows up in here. All right, and that there is a note is right here, and there's already an image attached to this object. I could double click that to bring up that image, and yeah, that's not quite working for some reason. I'm finding all sorts of things in doing this, but here's the image on the Images tab, and that's just a downloaded DSS image. Okay, so that is back to the attachments, a little bit more information. By the way, I can right click on this right here and change it. Well, that's pretty cool. And you'll see that there are other things you can customize as you go along. All right, so we have a difficulty here. So I'm getting back to the filters now. We have a difficulty, obvious, easy. So we can filter by difficulty. Let's just do obvious objects. Now it's just the obvious objects that are being listed that are at best quality. That's probably a good setting for a public star party, right? You don't want things that are hard to see in the eyepiece. So we're just going to go for obvious things that are at their best quality. And there's other aspects to this. If we go to apparent quality, then it's showing only apparent quality, and it turns out there was only one of them. Or we could say and less difficult. So now all the obvious, easy, up through apparent are being listed. Or I could say more difficult, and I'm not sure that actually worked right. I've been having a little trouble with this. Where that would really come in handy is if you set it to difficult and more difficult. Yeah, I think actually none of these objects are difficult in my 18-inch telescope. I think that's the problem here. But normally it would show all objects that are difficult, challenging, and very challenging. So that could be a useful thing to do, difficult and more difficult. But visible any difficulty is really probably all you're ever going to need, right? This is going to show you everything that it thinks you can see. So best quality and visible any difficulty, those are your two best filters to be using together. And we can, of course, drag our sliders over to limit that to a particular part of night just before. So it'll only show you these things that are within the time described by the time sliders, and we can put in numbers here too if we want to. Let's look at this is the Messier list. Let's look at double stars. Here, AL double stars. I'll load that list. Here we go. All right, so here are the double stars. Best quality only is still a really good idea. Visible is a good idea, but now we can look at splittability. We can say I want objects that are just difficult. All right, so now it's going to show us only objects that are difficult. Well, these are deep sky columns. It's not even showing us the difficulty columns. So let's go. We're going to click on the icon here, and we're going to add the double star data in, and we're going to look around and we're going to say, you know what, this type isn't very interesting for double stars, and certainly the diameter doesn't apply, nor does the size. And so for our oh wait, I forgot to click new here. For our double stars, I have no idea what that's going to do with it. We now have a double star column scheme, and it is showing us the splittability. Let me get rid of that best split. Not that useful. Okay, so this is saying that this double star pair, the BC pair of one cam, a 7th magnitude stars, the B 11.1 magnitude stars, the C is separated by 149.9 arc minutes, and it's easier than difficult. It's an obvious split because it's so widely separated. Okay, so that's how we narrow down double stars. I can also go, let's say it's looking at the BC pair. It automatically selected that. I'm going to right click on it, and I can then select auto select. Actually, it didn't. I actually had that already set. And it's going to automatically select the AB pair now, which is 10 arc seconds apart. If I right click on it, I can say I want the BC pair. And now it's giving me that one. Okay, so we can customize this, or we can just set it to auto. Auto actually works pretty well because it takes into account your telescope and the seeing conditions and things like that. To pick a pair that you're going to want to look at, although sometimes it tends to not show you the really wide pairs because it doesn't think those are as interesting as the ones that are closer together. So it's a little bit of subjective there. So that's double stars, and let me show you this new feature up here. I'm going to go back to the Messier list, and you notice I just selected it and double clicked on it. So here's the Messier list. We've got it set to best quality only, visible any difficulty, and this no longer really matters because there aren't any double stars. I'm going to click this sort button, and that's going to create an optimum viewing order sort. And the way that works is you tell it how long do you think it's going to take you to find each of those objects. And I'm pretty fast at star hopping, so I'm going to say it's going to take me 5 minutes, and because this is my job, and I just want to look at each of them for 5 minutes. So I could click on this and say I want to look at each of them for 10 minutes. When I turn it on, now it's created a sorted list throughout the night of objects that are at best only and that are visible in the telescope. And it says that I have an appointment with this object at 5:55 p.m. That's when I should start looking for it. Now, why did it choose 5:55 p.m. and why did it choose this object? Well, it chose this object because it's a bright cluster, right? Look at that, 5th magnitude cluster of stars. I can observe that in twilight. So it said, let's go ahead and start with this one in twilight. This next object, though, here's another bright cluster. This third object, though, that's M75. It chose that because it's setting. We've got a short period of time to get it. So it's saying, let's get that now. Next object, same kind of thing, same kind of thing. Well, eventually you reach a point where you've seen all the things that are setting. You've caught up. And at that point, it switches gears and it says, let's not move the telescope really far. I mean, we've been out in the west getting all these things that are setting, but now we've gotten all the ones that are setting. Let's just find the next object that's as close as possible to where we're at. So you see it went from the dumbbell to the Triangulum Galaxy, M33, then M32, then Andromeda. It's not moving a lot. So this eliminates that whole, let's go look way down in the south, let's go look way up in the north, down in the south, out in the east, west, or whatever. Puts it in a reasonable order, while still making sure you get those things that are setting right now. Okay, so this is an optimum sort. The reason that you have to put in a viewing time is because the night is moving along, right? The sky is moving during the night, and if you don't tell it how long you're going to look at each object and how long it's going to take you to go from object to object, then it's going to lose track of what time of night it is, and it can't really do a meaningful calculation. So that's why we have to calculate this viewing time. Now let's say I'm going through this and I really love the Ring Nebula, and I've got a special plan tonight where I want to look for this detail in it that I've never seen before. So I want to look at it longer than 5 minutes. So I'm going to right click on 5 minutes here, and I'm going to put in 15 minutes. Now it's going to recalculate everything, and that was weird. Wow. Okay. That was working the last time I tried it. I will fix that before it comes to you. But You're supposed to be able to enter in a custom time here, and then it'll recalculate everything based on that custom time, give you 50 minutes to look at it before it goes on to the next object. So that is the tour mode, or the optimum viewing order mode. And you can take this and say, print it out, or you can use it to print finer charts for the night and go from object to object to object. I think of it as having an appointment. So 5:55, I'm going to go see M39, and then at 6:05, I'm going to go off and look at M103, 6:25, M75. And you'll see that this same concept is used in some new tools for the real time, and we're going to cover those in the next video. I think I got all the major aspects of this, and I'll see you in the next video.